Hi. Okay, so kinetic energy is today's lesson. We're going to learn about the kinetic energy equation and then apply it to a variety of situations. Bit of a strange question. If you had to, if you really had to, would you rather be hit by a bike or a double-decker bus? A car driving at 5 miles an hour or a car driving at 70 miles an hour? A tennis ball or a cricket ball? Why? Personally, bike or a double-decker bus, I'd go for a bike. Actually, if you're in central London, bikes probably go faster than buses, but buses are a lot heavier than bikes, so the likelihood of being damaged by one or the other, I'd say buses are more damaging. Car driving at 5 or a car driving at 70? Well, at 5, I'd probably survive. At 70, I don't think I would. A tennis ball or a cricket ball? Don't know if you play either of the sports, but a tennis ball, um, round, obviously, soft, hollow, quite spongy. If somebody hits it, somebody like Roger Federer served a tennis ball at you, that would hurt a lot. Um, but a cricket ball is pretty solid. It wouldn't even take a professional to hit a tennis ball, a cricket ball at you, to have serious damage. So it's the mass and the hardness of the cricket ball, it's the speed or the velocity of the car driving at 70, and it's the mass of the double decker bus. And those things combined are going to be what we're looking at today, kinetic energy. Check. Why is it a good idea to avoid large objects moving quickly? Obviously, in that situation, you've got Boris Johnson. It's always best to avoid Boris Johnson when at all possible. But if you noticed recently, he was hospitalised for COVID, and he himself said it, he was obese, and his obesity made his recovery slower and the symptoms and his experience of it worse. He is a large object. So, and here he is playing rugby against some small primary school children, holding nothing back, probably killing a few in the process. He is big, they are small. He's probably slower than them, quite a bit slower than them, but he is a lot heavier. And heavier means he's going to have more energy. The energy he's going to have is kinetic energy. You probably know this from key stage 3. All moving objects have kinetic energy. It is a measure of how much energy is stored in the moving object. That's very important. Moving objects. To have kinetic energy, you have to be moving. If you're stationary, you don't have any kinetic energy. If you are mobile, if you are moving, you do have kinetic energy. Here we have two identical cars, a blue and a yellow Beetle. One is quicker than the other, so which one has more energy? Well, assuming they're identical in every other way, the quicker, the faster car has more energy because it's going faster. Now the cars are travelling at the same velocity, but one of them is heavily laden, it's full of luggage. The other is empty. Which one will have the most energy? The heavier car has the most energy. The heavier car were to hit you, compared to the lighter car, the heavier car would do more damage because the heavier car has more energy because there's more to it. The more massive an object and the faster it is, the more kinetic energy you'll have when it's moving. Important term there, more massive an object. The term massive there means to have mass, not as in massive as in really big. When people use the word, oh, something's massive, they often mean really big. But the correct term, massive, means has a lot of mass, which means kilograms, not weight. Weight is not mass, and that's weight is a force. So the more massive, the more kilograms that makes up an object, and the faster it is, the more kinetic energy. But let's do an equation. Haha. This is the equation. The energy, kinetic energy of an object is equal to half multiplied by the mass multiplied by the velocity squared. Simplified, E is equal to half mv squared. Kinetic energy, half times mass times velocity squared, half mv squared. Obviously, mass is measured in kilograms, velocity is in meters per second, and energy is measured in joules. Pause, take that down. Have you paused? And now you're ready to go. Excellent. So let's look at an example. A car with mass of 1,500 kilograms travels at a velocity of 20 meters per second. 1,500 kilograms is quite a big car. And 20 meters per second speed of about 40 miles per hour. So this car is moving. What's the kinetic energy of that car? The equation is half mass times velocity squared. So we have half times 1,500 times 20 squared. Half times 1,500 times 20 squared, which gives you 300,000 joules. Quite a lot of energy. Let's see though, sometimes the question won't be about working out the kinetic energy. It might give you the kinetic energy, and you have to use that to work something else out. For example, if you give it the energy, you might be able to work out the mass of the object or the velocity of an object. In physics, in quantum physics, they can use that to work out how fast an electron travels, or other energies of electrons, quantum stuff. It's pretty cool. Study that later at university. So we know E equals mc squared. E equals half mv. Okay, if we want to make the different subjects, what you have to do, if you want to move something, you just do the opposite of that function. So for example, if you're multiplied by something, to move it, you divide by that something. So here you've got E equals half mv squared. If we want to make m the subject, here, half, we're being multiplied by a half. So to move that to the other side, you have to divide by half. So half divided by half, 1. That cancels out. So you have to do the same to the other side. You're multiplied by v there, so you have to do divided by v squared there, which, when we work it out, is m over 2e over v squared. Notice, if you divide by half, that's the same as timesing by 2. So rearranging that equation is the same, gives you m 2 times kinetic energy all over v squared. Let me rub that out so we can put it on a different one. Okay, now let's look at it in terms of v squared. So actually, if we want to do the v squared one, it's almost the same. Look, we divide by half, that half has to come across, and we divide by the m. So we're now going to have 2e divided by the m, so it becomes 2 times e divided by m equals v squared. But we don't want v squared. What's the opposite of squared? Square root. So v is equal to the square root of 2e over m. I would suggest you maybe write down those 2 other versions of the equation to make it easier and faster for you to do the questions. Done? Excellent. So another example. A lorry has a mass of 20,000 kilograms and it has a kinetic energy 2.25 mega. What does mega mean in standard form? Hopefully you remember that mega is times 10 to the 6. So half mv squared rearranged for velocity is 2e over m square rooted, 2e over m all square rooted. So 2 times 2.25 mega, 2.25 million, all divided by 20,000 square rooted, 15 meters per second. So about 30 miles an hour. So a big truck traveling about 30 miles an hour has nearly 2.5 million joules of energy. It's quite a lot. Right, some questions. I'm not going to do this now. It's a good thing for you to do when you do this PowerPoint. I'll add this PowerPoint to the video, so make sure you do these questions yourself. Do you have a look at one? God. Whoa. A skydiver falls with a terminal velocity of 50 meters per second. How much energy do they have? What's the equation? It's half times mass times 50 squared. You can work that one out. Go on. We'll skip over this. Ooh. Here's an important thing though. How does the energy vary with its velocity? Normally, when you have one of these relationships, as you go faster, you normally say the energy might increase, and that does happen, but something different happens with kinetic energy. Look what happens as it goes along. Look how much more the energy is at the higher speeds than it is at the lower speeds. If you say, let's go from 20 to 40, if you double the speed, look what's happened to the kinetic energy. It's gone from 40 kilojoules up to 160 kilojoules. That's more than double. You've only doubled the velocity, but it's 4 times the kinetic energy. If we do the same, go from 40 to, 80 is not on here, go from 30 to 60, double it, 90 to 360. That's enormous. Why? It's because the velocity is squared, half mv squared. And so when you square it, it makes it much, much bigger. And so squaring it is much bigger value. Okay, use kinetic energy equation to fill in the kinetic energy values in the table below for 2 cars traveling at different velocities. So, what I want you to do is pause, copy down that table, copy down the table and work out what the different energies are. 10 miles an hour, 20 miles an hour and 40 miles an hour. So if 10 miles an hour is 4.447, 20 miles an hour will just be twice that. 40 miles an hour will be 4 times that. So can you use that information to work out the kinetic energy? Those ones. Pause, copy the table, work out the kinetic energy. Done. You notice, hopefully, that by doubling the speed, doubling the velocity, quadruple the kinetic energy. Because of that, v squared. So it's much more dangerous. So speeding is actually very dangerous in a car. 2 cars, roughly the same mass, but one's going 5 miles an hour faster. It's only a small amount of speed difference, but actually the energy increase is going to be a lot bigger because that 5 squared root 25, so it's like an extra large amount of energy on top. It's a really big difference. Speeding has a much more substantial effect on the kinetic energy than the mass of the object. There we go. Doubling the mass of an object doubles its kinetic. Sorry, doubling the mass doubles its kinetic energy, but doubling the velocity quadruples 4 times its kinetic energy. If the velocity of a car is slightly above the speed limit, its kinetic energy is much greater than it would be at the speed limit. This means it's much more difficult to stop the car, and there is more of a chance of an accident. Small amount of speeding, much bigger chance of accidents. And now it's time for you to answer some questions. These are quite simple questions, actually. I just want you to work out the kinetic energy of these different situations. The only thing that's going to be tricky is you've got to make sure you're using the correct standard form. So the first one, 600 kilogram mini, the car, traveling at 30 meters per second. A 200,000 kilogram aircraft traveling at 200 meters per second. A 3 kilo cat running at 4 meters per second. 65 kilometer boy running at 7 meters per second. Note this last one, a 5 milligram raindrop traveling at 2 millimeters per second. Number 2 is saying, how fast would a 50 kilogram girl have to run to have a kinetic energy of 900 joules? That's a rearranged equation. How fast will a motorbike and rider have to travel so their total kinetic energy is 337,500 joules? The mass of the biker and his bike is 750 kilos. So you need to change the equation to make sure B is the subject. Which is greater, the kinetic energy of a 45 girl running at 6 meters per second or a 60 kilogram boy running at 5 meters per second? 15 kilo difference, 1 meter per second difference in velocity, speed. A heavy lorry traveling along the motorway brakes to stop a collision. So it comes to a stop. Where does all its kinetic energy go? Interesting. You've reached the end. Good luck. I believe in you. Love you. Bye.